You guys ready?
No.
No?
Yes. No. He said that.
Take a minute to get ready. Because you know what? Today's going to be kind of tough. Last lesson we worked together, I'll be honest with you, it was tough. And I think that I failed to explain something to you. I was thinking about the lesson afterwards, and I was thinking about the work you did, and I was super proud of the work you did. But I realized as a teacher, and as a science teacher, I sort of goofed. I forgot to explain to you that usually in science class, the teacher's giving you a lot of the information. Yeah. And you're kind of listening, and then you're learning, and you're figuring it out as you go. But you know what? I sort of flipped everything around on you. And this time I asked you to read a science text, and I asked you to get the information, and I forgot to tell you it would be hard. I also forgot to tell you that you might not get it right away. And I also forgot to tell you that you shouldn't worry about that. Because if it wasn't making sense to you, I knew you were working hard. If it was feeling uncomfortable, that was a good clue that you were working hard, okay? And that by the end of our lesson together, we would learn a couple things. We would learn how to read hard science text so it does make sense to us, and we'd learn a lot about electricity, okay? So as we continue to read today and do our work, if it's feeling hard and frustrating and kind of uncomfortable, that's a good thing for you. Okay? Because you're learning new information. When we read nonfiction, we're learning new information, and it doesn't always make sense at first. Okay? But as we work through it together and we try out our new ideas, it will make sense. Okay? You have to trust me on that. At first it feels a little strange, and then we'll work through it together and it'll make a lot of sense. And you'll be able to use the skills and strategies that we worked on together in this text on many other science texts to understand new science information. Okay? So I did kind of forget to tell you that. I apologize. But now you know. If it's feeling hard and frustrated, you're not alone. And that's actually how I kind of want you to feel. Because when I read new science text, it is hard and I get a little frustrated, but I have lots of strategies on how to read that text to make sense of it. Okay? And that's my goal, is to teach you all the strategies I know so that when you read science text, you understand it. Got it? Okay. So, we're talking about electricity, electrical energy. We talked about how it can be transformed. We just reviewed a laptop and how the battery in a laptop can transform energy into heat. We can feel on our legs, if we use our laptop on our legs long enough, it can transform into light when you see that screen. And sometimes it can also transform into sound. Okay? We're remembering our I can statements. I can read a scientific text and explain what I learned using details from the text. We started that last time. We're going to continue it today. I can explain the necessary components of an electrical circuit. We started that last time. We're going to finish it today. And we're going to talk about how you can describe how electrical energy is transformed into light energy.
When are we going to use the light bulb?
When we are done understanding the words we need to use to describe what we're seeing with the light bulb. Okay? So hopefully we'll get to that today. And if not, it'll be in our next lesson. Got it? Okay. All right. When we read the last time, the first time we read it, we annotated the text. We circled unfamiliar words, we underlined important ideas, and we used question marks to identify some wonderings. Those wonderings help us figure out where we want to explore next in science. Okay? Because it's been a week and a day since we last looked at this text, what do you think a good reader is going to do first? If they haven't seen a text for a week and a day, what do you think they do first? Hunter?
Reread.
Yeah. Here's what I want you to do. I want you to reread it, and I want you to notice any words that you circled. If you now know what those words mean, or you have a better idea, okay, I want you to put a star next to them, okay? If you're still not sure, just leave them alone, okay? So everyone's going to start at the top paragraph and read down. Got it? Go. since you jumped in on the last part of the lesson, this time when you read, I want you to read with your pencil in your hand, and if you find a word that you don't know or you're not sure about, underline or circle it this time. Okay? Good job.
Mr. Reed, please call the office.
Today, I want you to really work on that second piece of finding those important ideas. Okay? And see if you can find a few more of them as you read it today. Okay? Good. What I'd like you to do today is as you read, I want you to notice if there's any more important ideas you might have missed that first time through and underline them. Because remember we talked about paragraphs help organize important ideas? So there should be something we think about that's important in each paragraph, right? Okay, so can you work on that for me as you read today? Good job. Next one. Do you have a pencil? Let me get your pencil. You got it? Okay. Sean, you notice you have a star here, here. Is this a star or a mark?
It's a star.
It's a star. Can you tell me about a place where you weren't sure about a word, but this time you changed your thinking?
I was sure about all the words.
Can you tell me why you indicated these spots with stars? What were you thinking about?
Well, you said the word, like an important word that you should start.
Okay. Can you tell me which word you think is important up here so you marked it? Why do you think that one's important?
Because it's the whole thing that we're talking about.
Okay. It's the main idea. How about down here? This is important. What word is that?
Conductors.
Why is that important to its text?
Because a conductor is anything that allows charged particles to flow through it.
Okay. So why might that be important to electricity, do you think?
Because if there weren't conductors, then the electricity wouldn't exist.
Okay. Excellent. Now, what I can tell is that you've read this closely. You know a lot about electricity. Okay. Can you tell me what you're writing in your book? You thinking about science experiments or is it science stuff? Why don't we think about questions we have about electricity? And you can jot them in here. Or
I don't have any questions about electricity.
There's no experiments that you'd like to do with that battery?
Except maybe turn the light bulb on?
Well, why don't we write some questions about it? Okay, Sean?
Okay, let's turn the light bulb on.
Okay, can anybody share out with me a place maybe they saw a word they weren't sure about last time, but their thinking's changed? They're a little bit more comfortable with it now. They understand it better. Anybody mark a place in the text? I saw some stars. It's going to be brave. Isha.
What is circuit, and I don't know what it means because after that, like in the text, it goes so.
What did you understand it meant in the text? What does the author want you to know about circuit?
It's like a closed pathway that there's electricity in and it's a closed pathway.
Excellent, excellent. It's a closed pathway. Brooke.
I understand particles more.
Okay, tell me how.
I learned that they're like pathways.
Pathways. Go back to that text and see if you can think about that a little bit more. What does the author want us to know about particles?
The energy source provides charged particles.
Okay.
That's what it is.
So they're provided by,
The circuit.
What do you think?
Oh, energy.
The energy what?
Source.
Source. Does the author give you an example of what an energy source is in that text? What example does the author give you?
One part is an energy source such as a battery.
A battery. So a battery can be an energy source, and an energy source gives off
It gives off energy to charge the particles.
charged particles, right. So we're starting to understand what all of these things are, but it is kind of hard to imagine, isn't it? Like, what does a charged particle look like? Why do you think it's hard to imagine that? What do you think? Anybody have any ideas? Why is it hard to imagine charged particles coming out of a battery and traveling in a circuit? What do you think? Kaylee?
Because we never see anything, or some people don't even know what they are, so
Exactly.
it's kind of hard to imagine something if you don't even have the slightest idea of what it looks like.
Exactly. Can we see electricity?
No.
We know it's working, right? But when we look at wires, and we'll be looking at our example later, do we actually see what's happening?
No.
We see the end result, we see the light, we feel the heat, we might hear the sound, but can we actually see these charged particles? No, so that makes it really hard to understand. So that's really smart of Brooke to be reading so closely and really thinking about what's being said there. Because when it's something we can't see, and that happens a lot in science, it makes it harder to understand. And that's our clue to kind of slow down with our reading and really think about it. Okay, good job. Anybody else? Okay. All right, so we're ready to go to the next section. And I'm just going to scoot ahead here. Last time we looked at that second section, and we talked about how the author was using the model of the string. What was the purpose of the model of the string? What did it help us understand a little bit better? Turn and talk with the person sitting next to you. Share your thinking there. What did it help you understand? What did it help you understand about circuits, Xavier? Say again?
You said it helps you understand.
Okay, so what do you need to do as a reader to fix up your misunderstanding?
That you didn't help me as much, like I already knew it.
Okay, what was the author trying to help you understand about it? What was the author's purpose in doing it, including that model? Okay, so how do we fix up our misunderstanding as a reader?
Like I understood it. I'm just saying it didn't help me with anything.
Okay, but the author put it in there for a purpose. What was that author's purpose? What do you think, Jack? Can you help Xavier understand the author's purpose?
So that you can understand what a circuit is.
Right. What important idea does the author really want you to understand in a circuit?
That electricity can go around in a wire until a little.
What is the word the author wants you to understand by tying the string together? I want you two to look back at the text and come up with that answer. Turn and talk, okay?
It was open pathway and closed pathway.
Okay, there you go. Where in the text did it talk about that?
Number 2.
Can you show me where? Can you point to it? There you go. Very good. Excellent. Okay. You got it? All right. What was the purpose of that model? Why did the author put that text feature in there? The structure of a model. What does it help us understand? What do you think, Abby?
It helps us understand how the circuit in a wire flows.
Okay. What important idea does the author want us to understand about circuits?
How circuit flows.
What about it, though? I know Xavier was just talking about it. He found it in the text for me. He went straight back to it. What was that important idea, Xavier? Open and closed pathway. What's important about open and closed pathways with electricity?
I didn't say that.
What's that?
I didn't say that.
I know, but I'm asking you. What's important? What do we need to know about open pathways and closed pathways when we're thinking about electricity?
An on and off circuit.
Can you be a little bit more specific?
An on and off computer.
Can you relate that idea, because you're right on the right track, to an open pathway and a closed pathway? How does an on and an off computer go with those ideas?
On it's open, close it's off.
Okay. Hot. Let's try and talk about what Xavier said there. He's thinking that an on would be an open pathway and an off would be a closed pathway. Turn and talk with your partner. Do you agree or disagree? And where in the text helped you figure out your answer? Turn and talk.
I kind of agree. This is my handy diagram.
Wait, all four of us?
No, partners. What do you guys think?
I don't understand the question.
Okay. He's thinking an open pathway would turn the computer on. And a closed pathway would turn the computer off. Do you agree or disagree? Why, Brooke? What would keep on going around? What's going around? What are we talking about here? Electricity. So, on, what kind of pathway would it have to be?
Like open.
Closed.
Why?
Oh yeah.
The electricity has to keep going around and around.
Okay. And what happens if we have an open pathway?
It will start somewhere it will end.
Okay. What do you think, Ishmael? Do you agree or disagree?
Well, I agree that if it's an open pathway, it's on. But because at home, I go on the train and I go on the electricity one.
Okay.
And I saw the inside of a wire when the switch is turned on for the light bulb.
Okay.
So it was just like a battery connected to a wire which is connected to the light bulb, and then the light bulb is connected back to the battery.
Okay.
I have a question.
So connected, is that an open pathway or a closed pathway when it's connected?
When it's connected, it's open because
Can you do me a favor? I want you to look in the second section and find where the author's talking about pathway and confirm your thinking.
Wait,
Okay?
I have a question.
Can you do that for me? I want you and Brooke to work on that together. Because Brooke's thinking one thing and you're thinking another, and I want you to use the text to confirm or change your thinking together, okay? Can you guys find the part in the text where it talks about that? All right.
I have a question. You know those wind-up cars?
Mm-hmm.
Are those electricity?
That is a great question.
Because they move
How
on
could we
their own.
find out?
By
would you have to do?
wiring up the car.
You'd have to open it up and take a look, right? That's an
Yeah.
excellent question, but I'd have to open it up and take a look.
Because I always see my neighbor just flipping over the car and like twisting it.
Yeah, my neighbor's always doing stuff at
That's a great
midnight.
question.
I'm like,
Jot that question down on your sheet, because that's a great investigation to
doing
figure
stuff
out.
with his cars.
So, what was your task here, Brooke and Ishmael? What am I looking for you to do?
How do you spell wind?
just do wind.
Using the
Wine?
Wine.
exactly. So can I see you working in the text right now?
Is that
Okay.
No, it's fine. We have the same.
How do you spell wine?
The best way you can, because I want you to get your thinking down. Okay.
But it looks like wind.
All right. So agree or disagree? What do you guys think? Disagree. Where in the text supports your disagreement?
It says right here that a circuit is a special closed pathway for electricity.
Oh, so open would be what? On or off? Oh. closed would be on. Do you all agree with that?
Yeah.
Excellent job. All right, come on back to me. Do we agree or disagree? And who can use the text to back up their agreement or disagreement? Kaylee.
I disagree because I kind of use the string thing, and it's the string where you start your finger at one place and it ends at another. It's called an open pathway, and that wouldn't do anything because it's incomplete.
Okay. Are we thinking about the on button or the off button when we're thinking about incomplete?
That's the off button.
Okay.
So, and a closed pathway would be on because everything's in place and it's working. So it would be going.
Why do you think this is a tricky thing to wrap our head around? What do you think? Say it again, Xavier? Yeah. How about the idea we're thinking about? Why would people think that an open pathway would go with on if they weren't studying electricity very closely? And a closed pathway would go with off. Why might that confuse people if we think about on and off, open and closed? What do you think, Isha? I'm sorry, Misha.
Okay. Because a closed pathway, because it's like, it might seem like it's just going around and it's not getting to the place that it needs to.
When we think about the word closed, does it sound like things are getting through?
No.
No. It sounds sort of opposite, right? Yeah. Closed and off sort of go together. Open and on sort of go together. But when we're talking about electricity, we sort of have to think about it almost in reverse. Exactly, Sean. Good job. So that's something to kind of think about in our head. All right, let's look at the third section of our text. Can everybody find the third section? I'd like you to number the paragraphs. How many paragraphs are in that third section of text that I marked off? Go ahead and number the paragraphs on your paper. Okay. Now the author is using a different structure here. Okay? The author's moving away from a mental model and using a different text structure to organize ideas. Okay? We see how many paragraphs, Hunter? 3. Can you put your chair down? It's going to make me nervous. I just imagine blood splurting. Ooh, not good, okay? That's good for biology class, not good for electricity class, okay? All right, 3 paragraphs. What I want you to turn and talk with your partner is how did the author use these paragraphs to organize the important information in this section? Why are there 3 paragraphs? Why is it not lumped all together? Okay? So turn and talk with your partner and use the text to support your thinking. So Abby and Sean, there you go.
3 paragraphs because they did the 3 paragraphs because there are 3 parts. 3 parts of electricity in a closed pathway. Sean, with your feet. There are 3 parts. Yeah. It's hard being a
For you and Xavier to follow the directions and talk about the organization. If you forget the question, it's right up on the board for you.
No, having our own roof. And we decorate it.
She uses bold words.
Yeah, bold words and they
Bold words.
yeah, they went like this. See, look, it's like this. It's like this.
Did you notice a pattern?
Look, dude, there's like the spaces. So like, here's one part of it. Here's the second part. Here's the third part.
Do you agree with them? Oh, yeah. Why do you think the author organized it that way to help you understand?
I think we got it.
Exactly. What might happen if he kind of lumped them all together? Or she?
You can decorate it any way you wanted. I have something
Okay, what might happen for the reader?
That's kind of what
Might make it difficult for the reader to understand if it's all together.
I like turtles.
Who doesn't? No, we had divided there.
What do you mean by part of the paragraph?
On the end.
That's kind of like what me and Jack said.
top doesn't.
No, you still would. There'd be
What does the author want you to understand in this section?
no one here. Only this way.
Right. And what might happen if it's all lumped together?
Do that if we raised enough money.
Do you think it would one big part? You might not see all three parts very clearly, right? Excellent. Very, very good. Would you be willing to share with the class since you did such a good job of noticing those patterns? Okay. All right. All right. Come on back to me. Come on back to me. I was just having a great conversation with Kevin and Nick. And Nick and Kevin, would you share with the class what you noticed about the author's organizational strategy there?
Well, it's 3 paragraphs because each paragraph has one of the parts. Like paragraph 1 has an energy sort, paragraph 2 has wires, and paragraph 3 has the load.
Okay, why is that important?
So it separates all the 3 parts.
3 parts. What might happen to a reader if the author doesn't use paragraphs to separate these 3 components of a circuit? What might happen to a reader when they're trying to understand? What do you think? Allison?
They might get confused.
They might get confused. This is all new information. So by breaking it up and giving it to you in small chunks, does it help you figure things out?
Yeah.
Exactly. So pay attention to how the author uses those paragraphs. But more importantly, sometimes in school and in life, you have to write nonfiction. When you have ideas to share, should you break them into smaller chunks for people to understand? Absolutely. It's a great writing strategy too. So understanding it as a reader, but also using it as a writer. Okay? I want you to think back to the last time, I don't know how old you were, you might have written a letter to somebody important. We just got past Christmas. I'm thinking of Santa right now. And I was writing a letter with my 5-year-old in kindergarten. When we write a list for Santa, and we want Santa to know exactly what we want Santa to bring to our house, do we write it all in one paragraph, all mushed together?
No.
What do, David?
You spread it apart.
You spread it apart. Why?
Categories.
Why?
So he knows the exact thing.
Exactly. It's an organizational strategy for writers. Very, very good. What other text features did the author use to show what's important in this section? I noticed Xavier and Jack were talking about some. What are some of those other text features they used? Isha. Bold print. Why is bold print important?
Because then you know the words that are really important in it.
Okay, very good. Did anybody else notice any other text features? All right, I'm going to call your attention to a sneaky one that a lot of people don't notice. And this is a really good strategy for all my science readers, okay? You ready? I gave you a hint. Did you notice any patterns? Are there any important words the author uses over and over again in that paragraph? I want you to work with your partner. Look for repeated words that might be important. Okay? You can underline them or circle them as you work.
Circuit? You think it's well, it's not the word. It's just
And electric current. I think electric current.
Nice job, Sam.
Did you circle electric current?
Oh, and then we did it.
I circled electric current.
I think you want to know something about
Current. No.
I just used the math.
Did anybody notice some words that are repeated in each paragraph in that section? Each paragraph in that section. Keep looking. There's some really great science words in that whole section. But look for words that you see in each section. The author keeps repeating them. Wants to stick them in your brain. Underline them. Okay? What are you noticing, Leo?
A lot of circuits.
Circuit? Yeah.
They
Anything
use
else?
particles twice. And conductors twice.
Very good. How about charged particles? Does that show up in each section? Or more than one paragraph?
I got another one. A. A is
All right, share with me. What are some of the words the author uses multiple times in that section? Yes. Circuit. Very good. What else? Hannah.
There was load.
Load. Very good. Sam noticed that. He was doing a great job with it. Kaylee, what else?
Circuit.
Circuit. Hunter, what else did you see? Circuit. Particles. Was it always just particles, or is there another word that goes with it? When we're talking about particles, what word does the author use? They kind of go together. Charged particles. Okay. Why do you think this author is using the same words over and over again? Do you think they don't have enough words? Why do you think they're using the same words over and over again? What do you think? Kevin? What do you think? Why would an author use the same words over and over again, especially words like circuit, charged particles, load? What do you think? Everybody turn and talk with your partner. You're thinking, why? Why are they important? What do they want you to do?
They want like in your brain. Yes, and you need to like understand. You need to know that. I'm a great guy. You're looking for just because you said a memory.
What was Nick's thinking on that?
They want to give you knowledge about what you're understanding.
What you're understanding.
Abby, go for Sean.
I like
I
turtles.
want you to understand
I like turtles.
about
doesn't?
electricity. Why are you using the same words over and over again?
Oh my gosh.
What does he want you to know as a reader?
I lost all the people.
No, it'd be a window.
How does using it over and over again in examples help you
A
understand
big
what it
window
means?
right there. I can see across Sean. And then I can have like a curtain and you can just pull it down. And I'm like,
So I called on you because I knew you'd learn yours.
oh, and right here.
You did a wonderful thought. You did an awesome job there. Would you be willing to share that with the class?
But like the flowers and
All right, come on back to me. Kevin, would you share, after we sort of talked about it, would you share that big aha you had? Why does an author use these words over and over again?
Because to help you understand what the word means.
Why does that help you understand what the word means?
Because sometimes repetitive words help you understand the meaning.
Very, very good. Okay. One of the things that readers of science texts do, I'll tell you what, they think they can kind of take a little shortcut. I'll read the bold words. I'll read the main heading. I'll get the big idea, I'll get the bold words, and then I'll just know. But what I want you guys to know is what scientists do is they really read super closely, just the way you've been doing with their text. They look for patterns. They look at the organization. What does the author want me to understand here? And they look at the words the author uses again and again to help me understand what those big ideas are. Because there's always more big ideas than just those bold words. Okay? Those are a great starting point, but the important information is not always in the bold part. Okay? So we want to know, as readers, what do I do with all of that stuff? And you guys have done some fantastic thinking about how the author wrote this science text today. And by thinking so hard about how it was written, you understand much more about what it was written about, the electricity. Who can tell me the three parts of an electrical circuit? What are the three components you need? Who can turn and tell their partner? Turn and tell your partner. What do you need?
Battery, wire,
Turn and tell your partner.
electrons, and
You already knew. Right. And you knew it quickly, right?
circuit, like particle.
An energy circuit
Yeah.
It's three particles. One part is an energy source such as that.
Excellent. What's the other two parts?
Like one is an energy source.
Wires are the second part of the
Circuit.
And the third part?
It's the load.
The third part of the circuit is called the
Load. It tells you the load, the circuit, and the energy source.
particles.
All right, who can tell me the three parts? Who can tell me? Abby, I see you marking them so carefully. Tell me what they are. It's okay, take a minute to find it in the text. Yeah. The three parts. Yep, can you tell me what they are?
One part is an energy source such as a battery.
Excellent. Second part?
Wires are the second part of a circuit.
And the third part.
The third part of a circuit is called the load.
Excellent. Can you give me two examples of a load?
Load can be a light bulb or a doorbell.
Excellent. By reading the text so carefully and thinking about the reading, the science just sort of sneaks into our brain and we understand it much, much better. Okay? So really, really nice job. What we're going to do next is I'm going to give you an organizer. Okay? And we're going to do a little bit of writing work. I'd like you to put your name at the top when you get it. You're going to work with your partner, but you don't need to have the same information as your partner, okay? It does not have to be exactly the same if you have a different way or a different order you want to put it in. But I do want to hear you talking about the ideas that you're putting on the paper, okay? Okay, so first step is your name at the top.
I'm going to ask when we can do the battery.
There you go. Jack, would you pick up your name tag for me? There you go. Xavier? There you go.
When can we do the battery?
When we're done with our words. I know. It's the best part, right?
Yeah.
Okay, name on the top. I see Isha's ready. I see Leo's ready. Elizabeth is ready. Brooke's
David's
ready.
ready.
David, you got yours?
Yeah.
Okay. Take a look at what this organizer is asking you to do. Okay? We have some of the most important words we need with electricity, and we have two columns. What's the heading on the first column? David, what does it ask for?
What information does the author want me to understand about this?
Very good. So we have to think about what does the author want me to understand about this word? That is a little bit different than just a definition. It takes a little bit more of a closer, careful reading. Okay? And what is the second column, Ishmael?
The second column.
What is it asking for?
The second column is what examples does the author use to help me remember?
That's right. Okay, we've looked at this text really, really closely. We notice the author uses lots of examples to help us remember things and understand the words that we're trying to learn about electricity. So let's look at the first example. Electricity. Some of the ideas the author wants us to understand, as we've talked about, are electricity has to or must flow through a circuit, right? Do you all agree? Okay. It can change into other forms of energy, and it can change into heat energy too. That's another important idea. What other ideas did the author give us about electricity? What could we add to that box as a class? I want you to turn and talk in your table group. What's another important idea the author wants me to understand about electricity that we could add in that first box? Turn and talk with your table. Go back to the text and find an idea. What was that idea, David?
Well, that electricity is very dangerous.
Where in the text did you find that information?
Oh, you didn't. No.
Okay, so remember, not what we know about electricity, but what the author wants us to understand about electricity.
It's dangerous.
Okay, can you show me where in the text that is? Okay.
Electricity
See, it's right there.
Okay. Abby, how about you? What other ideas? Yep, so what else can you find? I like how Abby's going back to the text. She's thinking about it. I wonder what Amisha could add or David could add.
When
Sean
you
could
turn on a light switch, you allow electricity to flow.
Very good. So turning on a switch allows,
Electricity to flow.
that's very important information the author wants you to know. What else, Amisha?
Electricity has many parts to it, like a circuit, energy source, electric current, conductor, and load.
That's excellent. Also very important. Abby, did you find one?
I lost it.
What else is important about electricity?
Electricity must flow into a circuit to do it.
Okay, very good. In order for what kind of circuit? What kind of pathway does it have to have?
A circuit that is closed.
Excellent, Abby. Good work going back into that text and sticking with it. All right, share with me some of the ideas that I did not include in this box. What else is important about electricity that the author wanted us to know? Amisha, would you share your idea with the class to get us started?
Electricity needs many parts for it to work. It needs circuits, energy sources, an electric current, conductor, and load.
Excellent. The parts of a circuit electricity needs is very important. What else, Brooke? Did you have any ideas with your group about what else is important about electricity? All right. Can you go back into the text and think about that? All right. How about over here, Hannah?
Sound.
What about sound? What does the author want us to know about electricity and sound?
That electricity can form sound.
Can be transformed. That's that tricky word. We're going to keep working on it. It's our big word for the whole unit, okay? But it's transformed into sound energy. That's another excellent example of important information. How about this table over here? Did you guys find something that's important? What else did the author want us to know that's important about electricity? Any ideas? How about you, Xavier? I love how Kevin and Nick are right in that text. They're looking and thinking really hard. How about Jack? Okay, because this is a table group working together. What ideas? What else is important?
It can power the computer.
Is that in the text?
No.
Okay, I love how you've got some ideas about electricity, but really we're looking straight into this text to figure out what does the author want us to know? What's important?
Charged particles.
What about charged particles? That's such an important idea, Xavier. What about charged particles?
Conductor.
Can you tell me a little bit more?
It's anything that allows charged particles to fall through it.
Can you say it again?
It's anything that allows charged particles to fall through it.
Okay, so tell me about how charged particles is important for electricity. Why is that an important idea about electricity?
It powers it.
What do you mean by powers it?
It lets it work.
Tell me what you mean.
It lets something that's electric work.
Okay, so the charged particles makes the electricity work?
Yes.
Okay, very good. Charged particles are very critical to electricity. That was a very important idea. Nice job going back to that text. So what I'd like you to do now is work with your partner on the remaining words, looking at the text and finding more than one idea about each word that tells information the author wants us to know. What's important about each one of those words, okay? And if the author gives us examples, include those in the second column. Not all of the words will have examples, but I want you to stay inside the text, okay? I know you can probably think of examples in your head from your own life, but I want you to stay with what the author uses. Everybody got it? All right, so I'm going to give you about 8 minutes or so to work on this right now. Go ahead and begin.
Why are we being filmed? This doesn't need to hear.
Okay, what I want you to do, okay, is I want you to look at each one of those words and go back to the text to find more than one important idea the author told us about each one. Yep, and that's the part that is hard, and that's why we have to stick with it a little bit. Okay? So let's start with the first one. Share the idea that you have there. When we're done with this part. Okay? So when we have at least more than one idea for each one of those, we'll be ready for that second part with the light bulb. Got it? Okay, so let's look at circuit. What idea did the author want you to understand? What did you include already?
Electricity flows through a circuit.
Excellent. What other important ideas does the author want you to know about circuits? And this is where working with a partner or a group can be very helpful.
Help me.
Okay?
Help me.
While Abby's working, why don't we get ready? Okay? What I noticed is that you've got your idea about circuit from the second section. What ideas does the author want you to know from the third section about circuits?
That it can go, it flows through a conductor.
Excellent. Jot it down in the box.
But I already did that.
Sean,
But the idea also goes with circuits. Okay. What did you have, Abby?
A circuit must flow through a closed pathway.
Okay, so a circuit's made of a closed pathway.
Here, I have one.
So I noticed that you started with a second section too, and that's excellent. I want you and Sean to work on what other ideas can you notice about circuits in the third section, okay? What other important ideas come from that third section? Got it?
Can't we just do 2 for each?
Okay.
Okay.
Share with me what you're working on there. Share with me what you're working on there.
the conductor.
Okay, share with me what information you're giving me there.
Only the vacuum.
Allows anything electric to flow through it, and allows the computer to work.
Okay. What is this column for up here?
I just have one.
To help us remember.
Say it again.
To help us remember.
What does that column ask for?
I have 4 more to do, then I'm finished. So.
Does he?
Can you read it for me?
Does the author use
What?
what examples does the author use to help you remember?
Very, very good. So if we look at conductors, what type of conductors, what examples of conductors does the author use in this section?
Charged particles.
I want you to read it for me. It's here. What is an example of a conductor?
A conductor is anything that allows charged particles to flow through it.
Okay. That's what they do, but I want to know what part, what the example of a conductor is.
Metal,
Okay. Very good. What else?
such as copper and iron.
Okay. Can you read that whole sentence for me?
Wires are the second part of a circuit. Most wires are made of metals such as copper or iron. Charged particles flow easily.
Okay,
through
stop for a second and slow down and think about what you just read. What is the example of the conductor?
metal,
What's made out of metal?
copper,
What's made out of metal?
wires,
Wires, very good. How many different examples of wires did the author give?
3,
Tell me what they are.
metal, copper, and iron.
Very good. Those are all different kinds of wires, which are different examples of
Charged particles.
Very good. So what belongs over here in this box?
Every single type of wire.
Exactly. You know what I've seen? You've really improved on your ability to go back to the text. And when you go back to the text, you can find information very well. Okay? Jack, what are we going to need to do to get you focused on the task? What do you need right now? What's standing in your way?
Mainly the text. Maybe mainly this.
Okay. So what could you do? If you're stuck on one part, what could you do?
Go to another.
Excellent. Now you can be unstuck. Very good.
This is the only one I know.
Okay. So let's think about a strategy to figure out another one that you're not sure of.
Like the only one I can describe. I know what they all are.
Okay. So what does the author want you to know about circuits?
What they are?
What does the author want you to know? We talk about circuits all the way through this. What are some of those key ideas the author gave you? Okay.
String.
What does they want you to know about the string in circuits?
Open pathway.
Excellent. And?
Closed.
Yeah, you got this. That's the big idea up here. What does the author want you to know about circuits down here? This whole piece.
What? How they make wires?
You got this, right?
Yeah.
All right.
Don't know.
You got it. Trust yourself.
Not very easy. I really need to trust my mom.
What does the author want you to know about conductors? I noticed that you figured out what they're made out of. What else?
A conductor is anything that allows charged particles to flow through it.
Why is that important?
Because that's what it is. That's what it
Energy source provides charge.
So do you think that's important to jot down? Okay. You got this. Hey.
Yeah, you do.
I don't care.
Energy source.
Unless you take it offensively. Stop it. Energy source.
Nice job, Sam.
Oh yeah.
Nice job.
So.
That's the example of it, right? Excellent. What does the author want you to know about energy sources? Yeah, you do. Check that first paragraph.
Energy source provides charge particles.
That's important to know, right?
You're an anti-safety.
And how does energy source and circuit go together? Yeah, you do. Well, take a look at that first paragraph again, where you found a word. You got this. What does the energy source and circuit have to do with each other?
It goes together because it's an energy source is a part of
Check that first paragraph. Check your thinking. Is she right?
Too loud.
What words tell you?
An energy source, such as a battery.
I told you got this. So what does it have to do with the circuit?
the electric circuit is part of the battery.
The battery is part of the... Can you have a circuit without an energy source? No. So, you got this. Right? Awesome. Awesome work today. Good job. All right, we've got about 1 more minute, and I don't expect you to be finished with the paper. Okay? You guys are reading so closely and pulling out such important information. Okay? But I want you to finish up the one you're working on, and then we're going to share a couple examples. Okay? about conductor? What's important?
Well, a conductor is basically a wire that the electricity has to flow through.
Excellent. Can you show me in the text where the author used this example? Or was that from you've got lots of information about in your brain about electricity, and that's okay,
That's just fine.
right? Does that come, this part come from the text or from your brain? Right. So what I'm looking for is what example does the author give you of a conductor? What does he tell you that conductors are in this section here?
Why is here straight?
What are conductors made out of?
How's that not appropriate? I like to write like this. I'm saying straight on the right side.
That's because I'm sitting straight, so I don't need it.
Excellent. So the examples from the
If I was
text
sitting
are...
sideways, I couldn't.
When I'm sitting straight,
Literally, that's
See the difference?
when I'm sitting
Awesome.
straight,
Good job.
I can't write
now I need
that.
to go like this.
Well, what does the author want you to know about electric currents?
I feel more comfortable. I can't go like this. Oh my god. I don't know how people do it. Unless I shift my body, or unless I stand up and write, that's the only way I can do it.
Okay.
Yeah.
Yeah.
Ow.
Ow. There's something in my leg.
All right.
Ow.
How about electric current? What's important about electric current? Did anyone get to electric currents? Everybody put your pencil down now, and it's okay if you didn't get there. But electric current is one of those tricky ones because we're talking about something we can't see again. What is electric current? What does the author want us to know? Kaylee.
That I think you need a completed circuit to create an electric current.
Okay, very good. You do need a completed circuit, a closed pathway, right? Excellent. Anything else that's important about electric current? What else does the author want us to know? What do you think? Amisha?
It lets electricity flow.
It lets electricity flow. It is the flow of electricity. We can't see it. We have to trust that it's there. Very, very good. Okay, we're going to wrap up today with one last question. So I'm going to ask you to do me a favor, and I'm going to ask you to turn your papers over to the back. Okay?
Oh.
Put your text on top. So I see a blank page. Text on top. Very good, Amisha. Sean, awesome direction following. Okay. And I want you to get ready to answer this question by talking to your partner. Why is it important to read science text very closely and notice the author's structure in order to understand? Why is that important? Turn and talk. Why is it important? What I'm looking for, my friend, is to hear what you and Abby are talking about when I ask you why is it important to read science text this closely and look at the structure. Turning and talking with Abby, that's what I'm looking for. Eye contact.
Don't read the text and see any
I've answered that already. I can't do it until we finish this lesson.
either do
And
it
one of the
wrong
things getting in the way of finishing this lesson
Exactly.
is you interrupting and asking that question over and over again. Okay? All right? So if you turn and talk with Abby,
what the formula
we'd be one step closer.
explosive.
Okay?
I know. No gunpowder.
All right. Why is it important as readers to read this science text this closely and use different strategies to look at the text structure? Why is it important? Amisha?
If you're trying to do some sort of experiment and someone recommended that you read this text before you do it, and you don't see any dangers or anything that might be bad, you might either hurt yourself or do the experiment wrong.
Excellent. Excellent. You might get hurt if you don't read it that closely. Any other ideas? Any other ideas? Kaylee?
You might not get all of the information you need, or there might be something very important in the text, and you just skip right over it, and you can't really do anything if you don't have the important information.
Excellent. And it might be hard to understand, right? And when something's hard to understand when we read it, we don't always feel the the best about ourselves. It gets frustrating, right? That's not a good feeling. I'm going to promise you that although this is hard at first, if you practice it just like anything else, you get good at it, okay? Oftentimes, I use lots of these strategies without even thinking about it. It's like tying your shoes. Do you think about how to tie your shoes?
No.
No, you just do it. It's just, you just remember. And reading like this gets that way too. You learn that habit of slowing down, noticing repeated words, thinking about structure. But it's hard at first, I did warn you. And you worked very, very hard today. I'm very, very proud of your work today. Thank you, everybody. Okay? Your next lesson with Miss Wickland will be lighting up that light bulb.